Today we'll be learning about partial fraction decomposition.
Partial fraction decomposition is the process of starting with a simplified answer and taking it back apart, like the act of decomposing the final expression to its polynomial fractions. Example 1 will be a linear factor.
Alright, so this is our equation right here. And first, we start by factoring out the bottom. And x squared plus 5x plus 6 turns into x plus 3, and then x plus 2. And then we put that under 2x minus 1. And then next, for partial fraction decomposition, we make two separate fractions where we put a on the top, and then the first part of the factor on the bottom, plus b on the top, and then the second part of the fraction. Alright, and then we want to create a common denominator, so we'll multiply all of this by x plus 3 and x plus 2, and then so that goes to a, b, and this one, and on this one they will both cancel out, and then on the a the x plus 3's will cancel out, and on the b the x plus 2's will cancel out. So we will get 2x minus 1 equals a times x plus 2 plus b times x plus 3. Alright, and now we want to distribute the a and the b to both of the factors, so we'll get ax plus 2a plus bx plus 3b. And then we want to sort out, we want to combine like terms, so we'll do ax plus bx plus 2a plus 3b. Alright, equals 2x minus 1. Alright, and now that we have that, we are going to take out an x from the ax and bx. So we'll get 2x minus 1 equals a plus b times x. And then we're going to just put the 2a and 3b into a factor, so we get 2a plus 3b. Now we are going to take these and set it up into an equation where we can use elimination to find a and b. So since this is multiplied by the x, we set a plus b equal to whatever's multiplied by the x over here. So we get a plus b equals 2, and then we do the same thing over here. So we get 2a plus 3b equals negative 1. And now, since we have these, we want to use elimination, so I'm going to do this. I'm going to multiply the top one by 2 in order to get 2a plus 2b equals 4. And then we subtract these, and the a's cancel out, and then the b's, you get b equals, and then you get negative 5. And now you plug in the b for this equation up here, so we get a minus 5 equals 2, add 5, a equals 7. Alright, and now for our final step, we plug it back into this equation over here, and we will get 2x minus 1 over x plus 3, x plus 2 equals 7 over x plus 3 plus, plus negative 5 over x plus 2.
Example 2 will be a quadratic factor. So this is a quadratic factor example. So the first thing that we need to do is to separate out the entire fraction into two separate fractions. And the first one's going to be ax plus b, while the second one is going to be c, just the constant. It's going to be ax plus b on the first one because the numerator always has to be 1 less degree than the denominator, and since the bottom is x squared, the top has to be x. The next step that we have to do is multiply by the common denominator for everything. So first we have to distribute it into c, ax plus b, and the entire thing. Alright, so the denominator cancels with the common factor on the left side, leaving just 3x squared plus 11x plus 8, while for ax plus b is going to be ax plus b times x plus 3, and c is going to be c times x squared plus 2. The next step is to distribute x plus 3 into ax and b, leaving ax squared plus bx plus ax, 3ax plus 3b. And then we're going to do the same thing with the c, leaving cx squared plus 2c. The next step that we have to do is collect the like terms. After that, we are going to distribute the x squared from the a plus c, the x from the b plus 3a, and we're just going to leave the 3b plus 2c. The next thing that we're going to do is we're going to take a plus c and set it equal to 3 because they're in the same grouping. A plus c times x squared is equal to 3x squared. And then we're going to have b plus 3a equal 11 because they're both being times by x. And then finally, we're going to have 3b plus 2c equal 8 because they are constants. For this example, we are going to be doing substitution. First, we have to set set a plus c equal to 3, and then put a by itself, making a equal 3 minus c. After that, we're going to plug in 3 minus c for a, leaving 3 times 3 minus 3, or c, plus b equal to 11. After that, we are going to distribute the 3 in for 3 minus 3, leaving 9 minus 3c plus b equal to 11. Finally, we are going to move the 9 on the other side and make the equation neater, equaling it to b minus 3c equal to 2. Then we're going to put this in down here, and then we're going to times it by the entire top thing by 3, so we can get ready to eliminate. After we've put in the 3 for the top equation, we're going to cancel out the 3b and then subtract 2c from negative 9c, leaving negative 11c is equal to 6 minus 8, which is equal to negative 2. After that, we are going to divide negative 11c by we're going to divide negative 11c by negative 11, and we're going to divide negative 2 by negative 11, leaving c equal to 2 over 11. Then we plug in 2 over 11 for c in this equation right here, making a is equal to 3 minus 2 over 11, which gives you a is equal to 31 over 11. Then we plug in 31 over 11 into a in this equation to equal 3 times 31 over 11 plus b is equal to 11. After that, we solve for b. 3 times 31 over 11 is equal to 93 over 11. We subtract each side by 93 over 11 to get b is equal to 28 over 11. Finally, all we need to do is plug in a, b, and c into the original equation. So we're going to plug in 31 over 11 for A. We're going to plug 28 over 11 for B. And we're going to plug in 2 over 11 for C.